3I Atlas isn't just another comet drifting through space. It's an interstellar object, which means it originated beyond our solar system. NASA science points out that its unusual orbit proves it doesn't belong here. It's just passing through before venturing back into deep space. That rarity and significance make it important. Studying such visitors enables scientists to understand how other planetary systems are formed and how their chemistry may differ from our own. This strange traveler, officially designated 3I/ATLAS, was first spotted in July 2025 by the ATLAS Sky Survey. This is a network of telescopes constantly scanning the heavens for moving objects. After it was detected, observatories across the world confirmed its path wasn't circular or elliptical like most comets. Instead, it's hyperbolic, indicating a one-way journey through our solar system. Data from JWST.com and Orbital Today reveal an extremely open trajectory and unusually high velocity. By late October 2025, it will approach the Sun at its closest point, then vanish forever. The time for astronomers to gather data is short, just a few months before it might disappear for good. But what really has scientists and NASA paying attention to is its chemistry. The James Webb Space Telescope recorded something no one expected. The comet's coma, the glowing cloud of gas surrounding it, is dominated by carbon dioxide. Normally, comets from our solar system have more water vapor than CO2, but this one shows the opposite. Roughly 8 times more CO2 than water, according to the JWST research paper published on ARXIV. That's a massive difference and has raised a wave of curiosity and concern. Why would something formed around another star system be so rich in CO2? Was it built in an extremely cold region, or could something else explain the imbalance? Even the comet's physical activity is odd. Observations show a strong jet aimed toward the Sun, a feature unusual when compared to most comets, which typically release gas in a balanced tail. Some scientists argue this is natural, albeit rare. Others think it defies our understanding of comet behavior. Whatever the case may be, 3I/ATLAS serves as a reminder of how much remains unknown about the universe beyond our immediate neighborhood.
We're saying that it's bullshit, it's a comet, why is he saying this? He's risking his reputation. But then as time's going on, they're going, whoa, this is weird.
NASA cannot ignore such a mysterious visitor from another star. The real concern began when 3I/ATLAS started showing signs that didn't quite match what scientists expected from a normal comet. After the strange CO2 readings, a few researchers began to wonder, what if this object isn't entirely natural? According to Live Science, Harvard astrophysicist Avi Loeb, known for his controversial takes on interstellar visitors, suggested that 3I/ATLAS might not just be a chunk of ice and rock. It could be something artificial.
Mysterious object, and that would be a great blessing irrespective of whether it's natural or technological. But if it happens to do a maneuver when it comes close to the Sun, the way spacecraft do, using gravitational assist from the Sun.
His theory doesn't claim it's an alien ship outright, but he argues that when an object behaves in ways that defy explanation, scientists should at least consider all possibilities. And that's what set the alarm bells ringing. What if this so-called warning signal isn't a sound or a message, but the object's behavior itself? The unusually high CO2 ratio, the asymmetric jet pointed toward the Sun, and the hyperbolic path. All these elements make it feel like 3I/ATLAS is different. Could it be a probe? A fragment of alien technology? Or is it simply a natural traveler shaped by an environment we don't yet understand? The questions sound wild, but history reminds us that breakthroughs often begin with uncomfortable possibilities. However, not everyone is buying the alien angle. NASA science and most astronomers strongly disagree with the artificial theory, stating that all current data support a natural explanation. They say it's a comet born in a colder, CO2-rich region of another star system, and its strange chemistry is exactly what makes interstellar objects valuable to study. According to NASA, 3I/ATLAS poses no threat to Earth. Its orbit keeps it at a safe distance, and there's no sign of anything technological about it. Still, the debate continues. If it's harmless, why does it act so different? And if it's natural, what kind of world could have created such an object? Whether 3I/ATLAS is a warning, a mystery, or just another cosmic visitor, one thing's clear. It has forced even NASA to look twice at the skies and question how prepared we really are for what drifts in from the stars. So, we all have a question. NASA isn't exactly in danger, but it's definitely under pressure, and that pressure is building fast. Ever since 3I/ATLAS appeared, this mysterious interstellar object has put NASA's observation systems, communication strategy, and scientific credibility under the spotlight. The problem isn't just what 3I/ATLAS is. It's how little we actually know about, and how quickly it's moving through our solar system. When something from another star system rushes past us, the world expects NASA to have all the answers. But this time, the answers aren't coming easily. What makes 3I/ATLAS difficult for NASA? It's interstellar, on a hyperbolic orbit, and moves fast enough to limit observation time. According to NASA science, it passes major planetary paths, then leaves forever after late October 2025. There's no collision risk, but the brief window creates urgency for scientists, as missing data means missing a unique opportunity. And then came the controversy. Some scientists, including Avi Loeb, raised the possibility that 3I/ATLAS might be artificial, maybe even alien technology. That single suggestion, reported by Live Science, sent shockwaves across social media and news outlets.
The research team of the Galileo project, we have 3 observatories monitoring the sky to check for any unusual activity in the coming months. We have also orbiters around Mars that could check for unusual activity there. So I think we should keep our eyes open and not assume anything, because it could be a black swan event.
Suddenly, NASA wasn't just tracking a comet, it was defending its credibility. People began asking hard questions. Is NASA telling us everything? If there's even a small chance this isn't natural, shouldn't we know? When public fear mixes with scientific uncertainty, the result is chaos. NASA now has to walk a fine line, giving clear, evidence-based updates while avoiding words that could fuel conspiracy theories. Internally, the pressure is even heavier. Tracking 3I/ATLAS isn't simple. Because it's coming from outside the solar system, its path doesn't follow the gravitational rules that Earth-based prediction models usually rely on. It moves too fast for long exposure images, and its brightness changes quickly as it reacts to the sun's heat. That means NASA and other observatories have to constantly adjust calculations and share data in real time. Every minor mistake could lead to wrong predictions about its position or activity. And in today's world, a single data error can turn into global headlines within minutes. So yes, NASA is feeling the weight of expectation. The public wants reassurance, scientists want answers, and the agency must prove that it can handle interstellar visitors in a time when space news spreads faster than ever. Even though NASA insists 3I/ATLAS poses no danger to Earth, the mystery surrounding its behavior and composition keeps people watching and doubting. After all, if something this strange can slip through our skies once, what else might be out there coming our way next? As we dig deeper into the mystery of 3I/ATLAS, current science gives us a mix of reassurance and intrigue. First off, according to NASA, there is no threat to Earth. They estimate the closest the object will come to our planet is about 1.8 astronomical units, far beyond the orbit of Earth. And in the safe zone, In fact, its closest pass to the Sun is expected around late October 2025 at about 1.4 astronomical units, just inside Mars's orbit. Again, no impact risk. But while we can breathe easy about safety, what we don't yet know is where this object came from, how it formed, and what it's made of. And that's what's making scientists lean in. Observations are ongoing from many observatories, including the James Webb Space Telescope, the Hubble Space Telescope, and the SPHEREX mission. These instruments are collecting size estimates, chemical composition, dust and gas emissions, and behavior as the object moves through our solar system. Here's where it gets truly fascinating. The chemistry being seen is unusual. For example, JWST infrared spectra reveal that the coma of 3 I/A TLAS is dominated by carbon dioxide rather than water, a ratio of about 8:1 CO2 to H2O, which is one of the highest ever seen in a comet-like object. Scientists are puzzled. Most comets in our solar system have far more water than CO2. So what does this tell us? It suggests that 3I/A TLAS may have formed in a very different environment, perhaps in a star system, colder or more radiation intense, or near what's called the CO2 ice line, where carbon dioxide condenses into solid form. And there are even hints of odd behavior. Some observations show jets of gas oriented in surprising directions and dust emission patterns that don't match typical comets. These don't point to danger, but they do point to the fact that our templates for comets, how they look, how they act, are being challenged by this visitor. So, yes, the science says, don't worry about impact or destruction, but it also says, pay attention very closely, because this thing is weird.
The sun is here, and the comet is here. The sun sends the solar wind to the comet, the tail goes behind the comet. Guess what? This comet is at the reverse side.
But is it nature or something else? We're gonna find out soon.
This moment is a rare window. We might never again get such a close pass of an interstellar object with this quality of data collection. That means 3I/A TLAS is giving us not just a spectacle, but a once-in-a-lifetime chance to peek into how other star systems build objects. It may rewrite parts of comet science, ice chemistry, and even our expectations of how foreign visitors behave. When we talk about the implications of 3I/A TLAS, we're really talking about 3 connected threads: science, planetary defense/monitoring, and public communication. Each of these is already being strained thanks to how weird and fast this visitor is. From a scientific perspective, 3I/A TLAS is a once-in-a-generation opportunity. Because it came from another star system and is traveling on a hyperbolic orbit, studying it allows us to compare the materials of other planetary systems with what we have here.
What's worse, the images that NASA captured right before all this, well, we haven't seen those because of possibly the government shutdown. If 3I Atlas is alien tech, this will be the make or break moment.
New data shows that its coma is dominated by CO2 at levels far above typical comets. And we've even seen hints of unusual metals, like nickel and cyanide in its outgassing. These alien system materials could tell us how planetesimals form under different conditions, maybe under lower metallicity stars, or closer to CO2 ice lines, etc. If 3I/A TLAS formed somewhere very different, it might challenge our entire class of comet formation models. For example, why is it releasing water at large distances where we don't expect it? That was found recently via OH emissions. So from a pure science lens, this is gold. But we must keep grounding claims in observable data and not jump to dramatic conclusions. In terms of planetary defense and monitoring, the presence of 3I/A TLAS raises both operational and strategic questions. Operationally, it's moving really fast, coming from outside, passing through the inner solar system in a short window. Observatories around the world have only a few months to capture high-quality data as it approaches the sun, then passes behind it and disappears. That tight window tests our monitoring systems. Can we predict its behavior? Can we track its outgassing jets? And can we estimate its size and mass accurately? Strategically, if interstellar objects like this become more common, and many scientists now expect so, then our alert systems, observation networks, and impact risk frameworks might need updating. While NASA is clear that 3I/ATLAS poses no threat to Earth, with its closest approach around approximately 1.8 astronomical units away. But still, when something from outside the system shows up in the inner region, our what-if risk models need to be ready, even if the chance of impact is near zero. Lastly, the public communication angle is huge, because 3I/ATLAS has odd features, greenish color shifts, anti-tails, unusual metal emissions, etc. And because some researchers, notably Avi Loeb, have floated the idea of, could this be something artificial? The media and public are already buzzing with alien probe narratives. That puts agencies like NASA under pressure to respond carefully, to walk the line between curiosity and sensationalism. NASA has already formally debunked the alien technology claim, saying the data support a natural object. So, one implication, how we talk about this matters. If we exaggerate, we risk panic or conspiracy. If we underplay, we risk missing public trust opportunities or under-communicating real science milestones. Because of all this, here's what to watch for in the near term. That kind of anomaly forces us to ask, what if our models of comet behavior don't apply here? As the object heads toward perihelion, its closest approach to the sun, its tail structure, jets, and emissions could shift dramatically, offering a rare live experiment. Tracking these changes isn't just academic, it's how we test theories about how planetesimals form in other star systems, how material from alien systems behaves, and how well our telescopes can keep up. On the monitoring front, 3I/ATLAS highlights the urgent need to sharpen our planetary defense and space observation capabilities. Some researchers have already proposed redirecting existing spacecraft, like Juno, to intercept or observe it more closely, though the feasibility is slim given fuel and timing constraints. Regardless, the debate is shifting. If interstellar objects may pass through our system more often than we detect, our detection network, alert systems, and rapid response mission plans may need an upgrade. Even though 3I/ATLAS poses no known impact threat, its very presence is a wake-up call for the monitoring infrastructure. To quote a recent article, scientists plan to intercept it physically in the future, not just watch it through telescopes. Then comes the public communication side, where things get messy. Rumors and drama around 3I/ATLAS. Some voices claim it could be an alien probe. Others worry it might release mini-probes that could reach Earth. One Harvard astrophysicist encouraged people to take vacations before October 29th because of possible undisclosed risks from 3I/ATLAS. On the other hand, NASA and most astronomers maintain that the data so far show a natural object behaving within predictable limits, with no threat to Earth. The tension between speculation and science is real. If exaggeration fuels fear, understatement erodes trust. The way agencies communicate about 3I/ATLAS could set the tone for how we handle future visitors from deep space. Could we one day launch a rapid response mission to intercept such an object? Studies suggest yes, but not for this one. In the warning framing, the real risk isn't that 3I/ATLAS will hit Earth. It won't, but that we underestimate what these kind of visitors can teach us, or that our monitoring and communication systems lag behind the speed of the narrative. The warning is subtle. Pay attention, collect the data, adapt our systems, and keep the public informed with clarity. As crazy as it sounds, The moment we stop treating strange cosmic visitors as curiosities and start treating them as practice runs for something we might not expect is the moment we're truly ready. In short, this isn't just neat space news. It's a rare window into the unknown, a test for our observation systems, and a challenge for how we talk about the sky when things don't behave as expected. And while the dramatic stuff, alien spaceships, mini probes zeroing in on Earth, remains speculative, the real warning is this: the universe may send visitors we're not fully prepared for. If 3I/ATLAS turns out to be perfectly natural, that's fine, but we owe it to our future selves to be ready for the surprise.